Okay, cool. It's recording. All right. So, how are you doing on assignment 1? Questions, concerns, thoughts, hate mail?
Yes.
Great.
Okay. Here's I wrote a couple of questions down. Give me a second. All right. So you have to, every time you make a change and then save it, use git add, or can you just skip that step once you've done that once?
Okay, that's a good question. So the 3 little stages are you make some change in any document, no matter what it is, text file or a big long piece of code or a video even, it doesn't matter. You save those changes. The git add tells Git to pay attention to those changes. Okay, so if I had a long list of files and I made changes in 10 of them, but I only wanted to send 5 of those files up to the online version, I would just say git add and then give it the names of those files. When we type git add space dot, that means everything. It's kind of like a shorthand way of saying pay attention to everything.
So
Right.
everything that's in our, for me,
In that,
git bash.
in that directory.
Okay, in the directory. Okay.
Yeah. So we'll go over this in the command line today, what that dot actually means, but it means from right here. So everything in this directory and all the subfolders and all that, you're saying, hey, Git, I want you to pay attention to these changes that I made in every file. Then git commit /m with your little message. That takes all your changes and stashes a little saved version of them. Okay. Then git push sends that saved version up to the online repository.
All right, I have a few questions.
Great.
More, I guess.
Keep them coming.
So the first one would be, what is the significance of the -m in the commit?
That tells Git that you're going to leave it a message.
Okay, so can I commit
You cannot
things?
leave that out.
Okay, because I tried that and it wasn't working. And so is there any reason why you can't just commit without a message? Is it just...
Yes, there's actually a good reason, but it's kind of hard to understand. The person who wrote this program, Git, his name was Linus Torvalds. He also invented Linux, modern Linux as we know it. So he's like apparently kind of an asshole, but really smart. He's got like a hyperbrain, and he wrote Git for him. And so it's not easy for like us mere mortals to figure out what's going on. All right. But that message is actually really important because you can have 30 different versions of some file stashed away in Git. That message lets you tell it which one that you want to pull out. And so if you've made some changes and you're like, oh crap, no, I want to go back to this other version from 5 days ago, that message lets you do that. And so he wrote it to where you can't leave out a message so that he wouldn't get lazy.
Okay, that makes sense.
Yeah.
So going off of that, could you then, while you're working on stuff, commit several different, I guess, versions and then push them all when you're done working?
Yep.
Okay.
The nice thing about pushing is that gives you an off-site saved backup online, and we'll see why that's important, because we can accidentally delete stuff or your computer can crash. And so if you are committing, it's usually kind of a best practice to go ahead and push it at least once a day. If that makes any sense.
Yeah. So committing saves it locally, and then pushing saves it on GitHub.
On GitHub. Yeah.
Okay.
All right. Other questions about assignment 1?
Yeah, can I ask one?
Yeah. Sorry. Go ahead. I have a question after you.
Okay. Beat ya. So, how do you transition from the first commit to the second to the? I tried to do the 10 that you said to get full credit, and do I type second commit, or how do I do that?
Any message you want.
Oh, okay. So it'll just transition. It's not just committing the first one. It'll
Right.
continue. Okay, it'll stack.
Yeah. People get really annoyed with having to type in messages for committing. They really do. And so there's even a program called Get YOLO, which randomly finds a scrap of text off the internet and inserts that as your Git message. But it doesn't matter what your Git message is, it's a reminder for you. And so in that first example I gave you, it was just first commit. That was just me reminding myself, this is the first time I pushed this online. You could name the second one or make the second one the message anything you want. A, B, C, D, or the names of your kids, whatever, doesn't matter. Of course, best practice is to try to make it something informative, but in reality, people's Git messages are almost never informative because they're just upset that they have to write one.
And the second part of that question is, do we have to go back all the way to echo or git add, or can we just continuously enter and commit and push commands?
You have to save your changes in your file, add it, commit it, push it every time.
Okay.
We're going to walk through it here as a group.
Okay.
Going real slow with the Git stuff because it's going to be so important. I mean, you're going to be turning in all your homework on GitHub, and so I'm going to make sure that you all understand it. Lacey, you had a question.
Yeah, so I messaged you earlier, figured that part out, but the part that says it's like 0.9 of the assignment, it says, oh wait, it's right before that it will ask for our username and password.
Oh,
So
yeah.
I got my username, we're good with that, but when I asked for my password, instead of like the cursor, it just has like a box with a key in it, and I'm not super sure what to do about that because it won't type after that.
Just start typing your password there.
Okay, I did that a minute ago, and it just came up with that fatal failed thing. So
that means you got your password wrong.
Okay.
Yeah.
Let me give that a try.
All right, maybe before the rest of your questions, I should share my screen with you and walk through this whole process. Does that sound good? All right, I'm gonna take it real slow, but if at any point I'm typing too fast or there's something you want me to cover again, please yell at me. Okay, I am going to share my screen. Can you see it?
Yes.
Great. Okay, first thing, I'm going to create a new GitHub repository. So I'm going to GitHub. I'm going to say new repository, data underscore course underscore Zon in all caps. I'm going to make sure that that is public, and I'm going to initialize with a README. Create repository. All right. So I've got a repository stored in the cloud, so to speak. I want to bring it to my local computer. So I'm going to copy the address. I'm going to take my terminal. Try to resize this so it's easier to read. And what do I type now?
We can do pwd, make sure you're in Git, right?
Ah, good one. Okay, where am I?
That's a home directory?
I'm in my home directory. So if I want to find my desktop, I can look around with ls. Oh dear. And there it is. So I have a desktop right there. So I can type in CD, desktop, capitalization counts. Lowercase d is a different character than uppercase. Okay. I look around, there's a bunch of stuff. Now what do I do to bring this from online to my local computer?
Git clone.
Git
And then
space clone, and then I'm gonna paste it in on my computer. That's Control-Shift-V, and hit enter. Cool, it worked. So now I want to make some changes to that README file. Walk me through it.
Type in echo. I just copy and pasted.
Some change, blah, 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 in
Yeah.
quotes. And then what?
Git add readme.md.
Nope.
Name of the file.
You have the 2 arrows first.
Those 2 arrows mean they send the output from echo to a file. So if I just say echo that and hit enter, it did it. It just stuck that on my terminal. That's not very handy. And so instead of sticking it on my terminal, I'm going to hit the up key. That does the last thing I ran. I'm going to add those 2, and I want to send it to what? README? If I type in REA in all caps and hit tab, that should autocomplete.
I think we're in the wrong directory still.
That's
We're still on the
right.
desktop.
It's
Yeah,
not.
I was about to ask that.
So I hit tab a few times and it doesn't fill in. That means I know something's wrong. All right, so I'm deleting all this. What do I need to do? PWD, I'm in my desktop. That README file is not in my desktop. It's in a folder in my desktop. Called what?
Data course Zon, all caps.
Yeah, right there. So I made that folder. If I look around, LS, scroll up here, there it is. Okay, so I do CD for change directory, data underscore, and I bet I can hit tab here and it autocompletes. Yep. Okay, now I look around, I've got a README file right there. Ready for a new terminal command? This one's fun. It's called cat. Cat RE, hit tab, it should autocomplete because there's nothing else that starts with RE in this directory. What does cat do?
It prints the contents of the file.
Yep, it prints the contents of the file. When I learned this, I always thought of a cat. They puke all the time. All this does is just puke up the contents of that file onto your terminal. Okay? Doesn't matter what's in there, it'll spit it out for you. So all that was in there was this. Hashtag data course Zon. Of course, that's what I see inside my README. If I click on this little edit button, it'll let me see the contents. There it is, data course Zon. I'm gonna go back, open up my terminal again, and try this. Echo some stuff, send it to readme.md. Now if I hit up a couple times, it'll take me to my last cat command. That's a nice shortcut, save you some time. Cat it out, and there it is, data course Zon some stuff. I'm gonna do this again. Echo some other stuff. Send that to readme.md. Hit up a couple times to recat that file. Data course on some stuff, some other stuff. One more time. Echo a third stupid thing. Send it to readme.md, cat readme.md. There, on its own new line. All right. So I've made some changes to this file just by echoing things to it as new lines. I could also edit it with like a little text editor. All right, I could open desktop, data course on, readme, and I could just new line of stuff, 5, 6, 7, 8, 9, 10. I can just start adding stuff, change this file, hit Control S to save it, and then exit out of here. Now if I type cat readme, all that stuff's in there. All right, so I've changed this file. That's what I was wanting you to do. This has been one change. Does that make sense? I know I made a lot of changes to it, but Git only knows about one change. Git has a memory of the file when it looked like this. So now, here's a new command. You want to write this one down, git status. That tells you if there's been any changes to your files since the last committed version that Git knows about. And so it says readme.md has been modified. Okay. It also says no changes added to commit. And so if I say git commit now, it won't do anything because I haven't told it to pay attention to this file. So what are my steps?
You got to add it to pay attention to it.
Git add, and I'll just tell it the file name, readme. Enter. So now if I go back up to git status, look at that. It shows up as green. Changes to be committed. Readme.md has been modified. All right, cool. Now what?
Now you got to commit it.
Git commit. Have to give it a message in quotes.
YOLO that.
Whatever. Done. And now what?
Push.
Well, let's take a look at git status again. Nothing to commit, working tree clean. That means I've already had these changes, they're committed, so now I can git push them. And at this point, every computer gets a bit different. Mine stays in the command line. Yours may pop out a little box that asks for your name and password. There's my username. There's my password. Got my password right. Okay. So now here I am back on GitHub. I'm going to click reload. Hey, look at that. It's all there. So it's online. Okay. So that was one committed change. I can actually see that up here. It tells me how many commits there have been. All right. So that's 2 commits. That's because the first one, the initial commit, and then the second one called whatever 1 minute ago. So there's 2 commits total. If I wanted to do a third commit, it's real easy. I just echo some stuff, send it to readme, then I can say git add readme, git commit third whatever, git push, geez on.
Here's a question.
Great.
So when you git push, that is pushing all of your commits. Can you specify what you want to push, or is it always everything you've committed?
You can specify. Let's not go there in this class.
Okay.
Because it starts getting pretty esoteric pretty fast, the way you do that. Not to scare you, but if I do ls-a, you'll see that I've actually got a hidden folder here called .git. I can move into there. It's got all this stuff. It's saving all these different committed versions on your computer, and the way that they're named is pretty wacky. All right. CD objects. So here's all these different little like saved committed versions. So that's how you do it. I don't like that. I think it's really confusing. So let's skip it for this class. You won't ever have to do that.
Okay.
And if you remember, this is the cartoon for Git. It's on our website. And the punchline here, right, cool, how do we use it? No idea. This is normal. Most programmers I know that use Git don't know how it works. And when things screw up, it doesn't matter. You just delete it, download a fresh copy from online. Okay. So here I am in my README. Okay. I'm going to go to my little Finder window, go to my desktop. Inside of Data Course Zon, there's my README. Great. I'm going to take this and I'm going to delete it. In the trash. CD, Data Course Zon. Oh, it's in trash already. Okay, it's gone from my desktop. How do I get it back?
You could just download a copied version from GitHub again, right?
Yeah.
Or restore your trash.
You could restore your trash if you deleted it that way. I'm going to show you something terrifying pretty soon. Git clone. See if I still have it pasted in there. Yeah. Okay, so I brought it back. Okay, so if I go into Data Course Zon, I look around, there's README. How do I show the contents of that file?
Cat README.
Cat README. There it is, complete with all the changes we made along the way. Okay, so that's pretty nice. Now, some of you got like 18 out of 20 on this assignment. You turned it in. Do you want to know why?
Yes.
Let me show you. So I've got CD, a folder on my desktop called Git repositories, where I store all of my Git repositories because I have a buttload of them. And there's one called Data Course. I'm going to have you download this pretty shortly. Inside of it, I've got all the student repositories. Here's fall 2020. All right, I've got Baldwin, Eads, Hall, Miller, and Nunez. So I can change the directory to Git repositories, Data Course, student repos. I can look around. Okay, there you are. Those are currently the 5 that I have. What's wrong with them?
The capitalization isn't a capital letter different from a lowercase letter.
Right. Now you may be thinking, Dr. Zahn, that's the stupidest thing I've ever heard. Who cares? whether it's capitalized appropriately. This was an object lesson. I did not figure that everyone would get it right. That's fine. The instructions said data course like that, and then your last name in all caps.
I had to go and figure out how to delete mine and then do a new one. I had to
Yeah.
look that up.
So I'll show you that real quick. This is important because we get into coding, any kind of programming. A capitalization makes a big difference. I've had students stuck for hours at home before asking me a question, and I say, "Oh, you capitalized that word. That's why." All right. Imagine the frustration of spending hours of your life sweating only because you capitalize something wrong. So this is an exercise in follow directions exactly when you're coding. All right. So I'm going to delete my data course. Data course is on here. Are you ready? You go to settings, and then you scroll all the way down into the danger zone. There's delete this repository. There's no going back. Please be certain. In fact, it's so worried about you making a mistake here and accidentally deleting it that it's going to make you type that just to confirm. I understand the consequences. Delete this repository. Done. Okay, it's gone. So that's how you delete it, and then you just start a new one with the correct capitalization. All right, any questions so far?
I actually have a question on that last one. Can you not just rename it like in your command and then like edit it that way?
That gets you into trouble, actually.
Okay.
Yeah, you can, but you have to know a lot more about Git to make it sync up. Otherwise, it starts throwing errors at you that are really hard to take care of. Yeah. So this is the safe way. It's still on my computer, right? So I still have data courses on here. All right. I just deleted it from the internet. So I can still have this on my computer, so I can save all my stuff. I can rename it what I want, make a little backup file for it, stick it in there. So you're not losing anything. You can kind of keep a little stashed copy. But in this case, we haven't done much, so the easiest way is to just delete it and restart.
Okay.
Okay. Now, other questions?
Is the TIE Fighter game fun?
It's one of the greatest games of all time. It was released in 1995, so it's kind of hard to find, but it's the best flight simulator ever made. Yeah.
Is that the one on Nintendo 64?
No, it's prior to that.
Okay. Sorry, off topic.
You want to push that to GitHub so we can download it?
Not a bad idea. I might get arrested, but yeah.
Yeah, I mean, GitHub could technically take that, right? I mean,
Yeah.
it's not only for text and for code; it's for anything.
Uh-huh. There is a hitch. Any file that's over 50 megabytes, you have to have a paid GitHub account. So if you have really huge files, don't go trying to push them to GitHub. You'll get errors. Yep. Okay. So in your assignment 1, do I link to it? I thought I linked to it. Perhaps not. All right, so go to GitHub. week1.com/gzon. I'm going to have you download all of the course materials onto your computer. So you're going to have all my code, all the assignments saved locally, code examples, data files, all kinds of junk, right? Reading assignments, all that stuff. It's here in something called Data Course. All right, so I'm going to click on that. I'm going to go here to Code and copy it. I bet you know what to do next. Make sure you're in your desktop, and then git clone. All right, so the result of this is that you're going to have two folders on your desktop. One that's Data Course, and one that's Data Course Your Last Name. This one might take a second because it's got a lot of junk in it.
All right, here's a question.
Okay.
I am currently in my data course file. How do I go back up into my desktop? Because when I do CD desktop.
CD dot.
Okay.
CD dot dot means one backwards.
Awesome.
And we're going to have all next week, we're going to spend learning these command line ways of moving around stuff. I don't want to jump too far ahead and explain why that means back one yet. But CD dot dot means up one.
Do you have a good command list that we should be focusing on?
Yeah, it's on the website.
Okay.
But it's in week 2. So I don't worry about it too much until you're really comfy with the Git stuff that we've done so far.
Okay.
All right, so that eventually actually downloaded. Okay. So if I look at my desktop, I've got Data Course and Data Course My Last Name. You need to have those two folders on your desktop. Let me know when you do have them.
I have both.
Okay,
I also have both.
that's 2.
I feel like I should have it, but oh, there we go. It's just data course, not data course on.
Right, yeah. So you'll have yours with your last name and one that's just called Data Course.
Okay.
Mine is at 50%, so it's not there
Okay,
yet.
it's just taking its time.
Mine
So-
loaded, but I'm not finding it in my files.
In your desktop,
Yeah.
type
Like,
in
Was there a
PWD.
top thing I was supposed to do within?
So what do you get when you type in PWD and hit enter?
Just says dash users dash and then my name. Am I
Okay.
in the wrong spot?
So then you're going to have to say CD desktop.
With a capital D, right?
Yeah.
Do you have to do the backslash after that?
No.
Okay.
Okay, so I did CD desktop and then is it
Then
just,
LS.
oh,
LS is list.
uh-huh.
Lists everything I can see in that desktop folder. And here it's showing me both of mine.
It's just showing me the one with my last name.
With your last name? Okay, so go ahead and just do git clone and then my data course one again.
Okay.
And that'll make sure that it sticks it in your desktop.
Okay, then I should just be able to do ls again.
Yeah, as soon as it's done downloading. What you're going to be getting is all of these folders. So you're going to get a folder called data course. Inside of that, you're going to have assignments, code examples, data, exercises, readings. It's a bunch of stuff.
Okay, mine's still just having data course with my last name. So maybe I'm doing something wrong here.
And this git clone command, it definitely worked.
Yeah,
Is it still loading it on there?
it says 100%.
Let me zoom up. When you see that, checking out files done, that's when you know it's done.
Okay, it says done for all of those. I just don't know. I just got it one more time. Git clone.
Now, make sure that you have the address for data course, not data course Bowen.
Okay, just looking at that too. All right, it's just loading again.
All right. Another way to check is just to use your little like file browser. As a matter of fact, you can actually see files kind of turn up there in real time. It's kind of a fun, nerdy thing to do. I'm gonna touch Z, and then over here it's gonna pop up. Bunk! There it is. Just an empty file.
Okay, I got mine.
Got it?
Yep.
Cool.
Thank you.
Okay. There's another git command we got to learn, and that's git pull. But first, I want you to go into data course in your terminal. How do you do that?
Change directory data course.
Yep. As a matter of fact, I'm just going to type in data and then hit tab, and it auto-completes it. If I hit tab again a couple times, it's going to show me the options that match that. So it shows me that I've got something called data course and something called data course zon. So I'm just going to hit enter. Now I'm in data course. PWD will confirm that for me right there. So this is directions for my computer to get to data course. There I am. I'm going to do ls to look around. We've got assignments, data, exercises, readings, code examples, and then a bunch of random stuff. Okay. Now this repository is mine. It's just resting on your computer right now. Does that make sense? It's living in my GitHub account. You stole it from the internet, brought it to your computer. You can make any changes you want to it, but you can't push those changes online because you don't have my password. Make sense? But what I can do is I can make changes in this repository, push them online, and then you can pull those changes down into your computer. I'm going to do that. I'm just going to make a new file. I'm going to say echo some stuff, and I'm going to send it to new file.txt. All right, so you don't have this in your computer. It's not up online. It's just in mine. But since my repository is linked online, I can send it there. And what are the instructions for getting it to online?
You gotta push it.
How?
Git push, and then, yeah, just git push.
Did you not have to add it first?
Oh, I do have to add it.
Git add, git commit -m, then git push.
All right, I wanted you to see this. This is the error you get if you try to push something when no changes have been committed. Well, it's not really an error. It just tells you, hey, idiot, you didn't make any changes. All right. So yeah, I do have to add it. To see that, I can say git status, and it says, this file is not tracked. If you want Git to track it, you have to do git add file name. Okay. Git add new file.txt. Then what?
Commit it with a message.
With a message. Now I can push it. Username. Password. Okay. So let me check online here. I don't see it there, new file.txt. If I reload, there it is. And I click on it, and there's the contents. Okay. Now I want you to have this file. And so what you need to do is be inside of my data course folder. You should be there if you haven't been moving around, because we did CD data course from our desktop. This one's real easy. Git pull, enter. Mine says already up to date because I already have that change. Yours will show you some different stuff. So go ahead and type in git space pull. Did it work?
Yeah, I have the file now.
Okay.
Yes.
And to see that file, I can do ls to list the files there, and there is new file.txt. You should have that as well. Okay. So here's a not hypothetical scenario. It's time for exam 1. And I say, all right, I want you to go to our exam repository and pull down exam 1. I just sent it there. So you're going to basically clone this repository onto your computer right there. Clone it, and then all you got to do to get exam 1 is type in git pull within that repository, and you've got it. Okay. That is not hypothetical. That's how your exams are going to work. If I've got a new data set and I say, hey, I found a new data set for us to work with, do a git pull on the data course repository, what are you going to do? You're going to navigate in there, make sure you're in desktop data course, and you're just going to say git pull. You'll get the new file. All right. It's kind of a lot. Cognitive overhead here is steep. I get that. So questions?
Dr. Zahn,
Yes.
when I did git pull, it gave me the fatal error, unable to access the HTTPS, the website name, and then could not resolve host.
Okay, can you type in PWD and tell me the results?
Yeah, it just gives me, like, it's got the username and desktop and data course.
Okay, so you're in the data course there.
Yeah.
All right, I want you to try something. This will be confusing. I'm going to type it out, and I'm going to put it over in our Teams area, the copy-paste code. Do you know where that is?
Like on the chat?
Yeah, like so right here in copy-paste code. I'm going to paste the command in there.
Yeah.
And I'm going to let you all know right off the bat, I don't know what I'm doing, so you get to watch me flail around here. All right, so if you're in data course, try typing this in. There it is. So just copy paste that and tell me what your results are from that.
Oh, okay. I will do that.
All right. What may be happening, and this sometimes I don't understand why, is this HTTPS, the secure version of the website, doesn't play well with some computers. And so if we remove that S, it might fix it. All right, so you should see something like that. Whatever you see there, we copy that and paste it into our copy-paste chat.
Yeah,
you may
sorry.
have.
My computer was just being a little slow.
Oh, gotcha. You may have to right-click and do copy, because Control-C doesn't work in the terminal. For me, it's Control-Shift-C. For you, it might be like Shift. I don't know.
But it will have our name in there instead of G's on, right?
No.
No? Oh, crap.
Because we're working in my repository.
Okay.
If you're in your repository, that's a different thing.
Okay.
So it has my name there because I am in desktop data course, not desktop data course hacking.
Okay.
If you are in desktop data course hacking, you need to get out of it and go to desktop data course.
Okay. Doing that now.
And to do that, you'll want to do cd space ... and then cd data course.
What does that CD ... do?
That goes back one.
Oh. Okay.
We're about to learn all those fun tricks as soon as everyone's caught up. URL, HTTPS, GitHub. Okay, so Carlos,
Yeah.
it looks good.
Mhm.
That's what we should be seeing. And when you do git pull, it still just says fatal error, can't resolve host.
Now it's doing something different. Now it added it. So we're good.
Oh, we're good? Okay. I was going to say what that's might be is just like a weird internet dropout. So yeah, when in doubt, try it a couple times.
Okay.
Sorry about that.
No, thank you.
Looks like we got you fixed up though. All right, so that git pull is real handy. Now, a lot of people use GitHub to collaborate on code with people. All right, so if you both have access to the repository, one person can make some changes on their computer, send it up there, and then the second person can pull in those changes. And so it makes working on things really nice. In this class, we're going to use it as your personal repository. I don't want access to yours. okay? I don't want you to have access to mine. So don't give anyone your GitHub password, anything like that. Just we're using it as a place to store our stuff online. If something gets screwed up, we can always pull a fresh copy from the internet. All right. So I want you to be there in that data course. You should, if you type in ls, you should see new file.txt. That means your git pull worked. Okay. Now let's work on navigating. This gets kind of weird. Usually, I bet most of you are familiar with navigating through a computer this way, right? That's good. It's handy. You can do that, but we can also do it on the command line. Okay, and you already know the first one. That's just cd. That's change directory. But if I say cd desktop from in here, it's going to say no file or directory. Why?
Because there's no desktop when you're that far in. There's no desktop into your working directory that you're in, right?
Right. I'm here. You can see at the top of mine, it says I'm in desktop data course. And so, if I look around with ls, I don't see anything called desktop. And so when I say change directory into desktop, it can only move into directories that it can get to from where it is.
You'd have to go back twice, right? Into just like your profile.
So if I did cd .. // that works. Confused?
No.
Yeah. That means I went back to and then forward into desktop. And so I went from data course, let's see, PWD. So I went from data course into desktop and then into JSON and then forward back into desktop. And I wrote it all in that one little command, .. /.. That means go back one and then go back another, and then you can go back forward into desktop. That's a really dumb way of going into the desktop when I could just say cd .. because that would also take me into the desktop.
So a slash tells the computer end of that command, start of next one.
No, not exactly. The slash is part of an address. Now I want you to think about this little blinking cursor right here. Think of that as like a little friendly gnome or something. It's walking around inside your computer, and you can feed it commands and it will give you information back. We already know one of those commands is ls. So you're just giving instructions to your little gnome. You say, hey buddy, ls. And it says, here's what I see from where I am. Okay, these are the doors I can go through. I can go through the assignments door, or code examples, or data, exercises, or readings. And I've also got these files that I see here. All right. I can say, hey, little buddy, PWD. And it says, all right, this is where I am. All right, so PWD is kind of like, where are you? And LS is, what can you see from where you are? Now, if I say LS and my little friend says, okay, this is what I see, and I say, all right, I want you to go into the data door. What do I type?
CD data.
Yeah, CD data. And now I can say, hey, where are you? PWD. All right, well, I'm starting at the very base of your computer, the root. I'm in a directory called home, and then from there, I went through a door called JSON. And then from there, I went through a door called desktop. From there, a door called data course, and from there, a door called data. So the little slashes indicate a directory pathway that you've been through.
Okay.
So they don't really mean end of command. They mean
You're going through a
directions.
different door.
Yeah. So they're just directions for your computer to get from point 0, which is just a single backslash. In computer science, we call that the root of your computer. Okay. It's just directions from your root to where you are now. All right. So if I'm in data and I say ls, oh crap, that's a bunch of stuff. Do you see that when you type in ls in your data? Does anyone see different things?
Yes.
What do you
Well,
see?
I don't see different things. I see that.
Okay. There's a bunch of junk here. Now, you're all biologists, right?
Yep. Botany.
More or less, yeah. So you're going to be working with DNA data at some point in your lives, like in this class. Hint, hint. All right. This .fasta is a common way of storing genetic data. Okay. Particularly for next generation sequencing, the kind of sequencing that happens nowadays. All right. So I want to look at that file, fungalseeks.fasta. I want to look inside. How do I do that from the command line?
Did you just change your directory to fungalseeks.fasta?
That's
do
not
cat
a directory.
fungal sex.
Or
You would
cat?
do cat fungal
That's
sex,
a
right?
file. Yeah, let's cat. Cat, and I'm just gonna type in fung and then hit tab. It auto-completed because nothing else started with fung. I'm gonna hit that. Well, that looks fun. Let's see, scroll up here. Okay, we ran out of room. Is that basically what you see with cat?
Okay, mine cut out for a second. How did you do that from the page right before that?
All right, so I'm here in data course data. I look around and there is a file called fungalseeks.fasta. I say cat fung and then hit tab for autocomplete so I don't have to type it and make mistakes. So cat fungalseeks.fasta and then just hit enter and it's going to spit out a metric crapload of DNA data.
Okay, mine worked.
All right, let me tell you about this kind of file. FASTA is actually really common. A lot of bioinformatics pipelines use this file format, and so you're going to see it pretty often. It's an every other line format, and so we start a line with a greater than symbol, and then the name of that sequence. I know it's a stupid name, but that's one line, and then the second line is the actual sequence. And then it just repeats. And so it's name of sequence, the actual sequence. Name of sequence, the actual sequence. Okay. But this was really huge. So I'm going to teach you another nifty command. And instead of cat, which spits out the entire contents of the file, even if it's like 20 gigabytes, this one, head. What do you think that does?
Just the names of the sequences?
Well, I'm going to hit enter.
It's the first 10 lines, isn't it?
It is the first 10 lines. So head lets you look at just, it's like taking a little sneak peek. All right. That can be really handy if you don't want to, if you have a giant file and you don't want to spit the whole thing onto your computer, you can just take the first 10 lines and take a look at it. I can also say head -2 fungalseeks.fasta. What do you think that's going to do?
First 2 lines.
First 2 lines, yep. And there they are. So we've got one line. It's actually wrapping around here. You can see that's just one line. And then the second line. So that's the name of a sequence, and that's the actual DNA sequence. Okay, I would like to count how many sequences are in this file. Are you ready for this? Yet another terminal command. WC. What do you think that stands for? Any guesses?
Word count. Word count.
Yep. And by itself, if you just type in WC and then the name of a file, it's going to give you 3 numbers. What do you think they are? The number of words, or sorry, the number of lines, the number of words, and the number of characters. Yep. So I can say WC-H, and it's going to give me a little help file. Oh, no. It actually wants me to type out -- help. Okay. WC -- help. And it's showing me these little flags that I can use. This -- help comes in handy. So we just used head -- help. And it's saying, oh no, I can't help you. Oh, there it is. So you can say, print the number of bytes of each file, or just the number of lines that you want. So -2 gave us the first 2 lines. Now word count help shows me a few other flags. There's one called L. There's a capital L that shows me the maximum line length. We've got show me the number of words in this file. So if I say WC-L fungal seeks.fasta, that's going to give me the number of lines. 4068. So how many DNA sequences do I have?
Assuming that one sequence is a line, 4068.
But we know that one sequence is not a line.
It's 2 lines per sequence, so 2034 or whatever it ends up being.
Yeah, 2034. It is 2 lines per sequence. This makes another assumption, though, that there's no like blank lines in here. Do we know if there are blank lines in this file?
Not unless you go and look. Wait.
We'd have to go look at every single one. Okay. So, are you ready for yet another shell command? grep. This one's pretty nerdy. It looks for things inside of a file. And what it stands for is General Regular Expression Pattern. Okay, so it lets you search for things inside of a file. And the way it works is, in quotes, you're going to put a pattern that you want to look for, and then the file to look inside. All right, so if I would look for GTAG that, I'm just going to copy that. I'm going to paste it in there. What grep does by default is it spits out the lines that match that pattern inside that.
So that's your enter. Control F. That's like your Control F for...
Yeah, inside of a file, but it works way, way faster. And it can work on files that are 20 gigabytes big, and it spits it out real fast. So here are all the matching sequences that had that pattern. So that's already pretty handy. Now grep has a buttload of different things that you can feed it, those little flags. These flags, the little like hyphen, whatever character, they change the behavior of grep. Okay. So one of them is I could say print out the line number along with those output lines. So let me try that. I'm going to hit up a couple times, grep n that pattern fungal seeks, hit enter. And so now it's showing me the contents of each line that match that pattern, but it's also giving me the line number. Okay. What do you think that's going to do? And make sure that that's in quotes.
So when you did 2 of those, it was sending something somewhere, right?
One will also send it there, but if you do one, it overwrites the entire file instead of adding a new line. Many a file have I destroyed by doing that. Don't hit enter there. That will overwrite that entire file with just the word grep. So in quotes, you're safe. This is why we always put grep in the pattern in quotes. What do you think that's going to do?
So I'll find the beginning of every line,
Not every line,
every title.
because remember, head.
All the ones that start with that pattern.
Yeah, it's going to find all the lines that have that pattern in it. That's not going to be present in our actual sequences, so it's just going to spit out the lines with the sequence names on them. So if I say grep in quotes that fungal seeks, look at that. It's just a list of the sequence names. All right, now I'm going to blow your mind.
I was just gonna say, so if you want to switch to like a different sequence you're trying to find, you just do grep and then that new sequence.
Mm-hmm.
Okay.
Yep. And it gets a lot more powerful. We can write little loops that'll search for 10 different sequences all at the same time, all kinds of stuff. But I'm going to try to keep it a bit simple right now because I'm about to throw something crazy at you already. All right. If you don't get this right now, that's fine. We only have like 10 minutes left. We're going to be going over it quite a bit in assignment 2 and all next week. I'm going to hit up. So I've got grep greater than, in quotes, fungal seeks, and it gave me this. Should be like 2,034 of them or whatever, okay? Now, there's a little backslash button on your keyboard. If you hit shift that, it does that little vertical line. That vertical line is real special. That's a pipe. What it does is it takes the output of whatever is on the left side and it feeds it to become the input of the right side. So grep greater than, in quotes, fungal seeks, spit all this stuff out onto my screen. Now, if I want to count the number of those different lines, I can do word count L right there. A lot happened with that simple little command. First, we found all the lines that have that pattern in them from the fungal seeks file. And instead of spitting them out onto our screen, we fed them into this new program called word count. And we said, just give me the number of lines. So these 2 short little commands, grep that, and then word count L, tell us the number of sequences in that file. Okay. So this is where this command line starts becoming really powerful, is that we can chain together all these little programs into a longer, complex statement. There aren't very many command line commands that you're going to have to learn before you're already a pretty powerful command line user. If you know cd, ls, pwd, grep, word count, head, tail, What do you think tail does?
The opposite of head.
It's the opposite of head, right? It shows you the last n number of lines, right? If we throw in another one called cut that we'll get to, and paste, honestly, if you know how to use these, you can do some really powerful bioinformatics that work on giant files or even thousands of files at a time really fast. So let's take a look. I've got fastaexample.fna and fungalseeks.fasta. I've got these called fastq. Those are a bit weird. I'm going to take a look at that one. Head small fungi 10 r1.fastq. This is the raw data that comes back from a sequencing machine. Okay. If I look at them, these are pretty small files. That's just because I've taken little bits of them. These files tend to be like hundreds of megabytes in size when they come back from a DNA sequencer. If you tried to open these in Microsoft Word, it's going to crash your computer. All right. So command line is really the only way to work with files of that size from like a DNA sequencing machine. And that's because it only works at one line at a time. So it doesn't have to read that huge file into your computer's memory, save it there, and then work on it. It looks at things one line at a time. So with the command line, I'm just going to show you something. I can say grep a plus, because that's what's here separating sequences in my fastq file. It's a different file type. And then send that to word count L. Grep blah 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 of star dot fastq. This is the total number of sequences in all 4 of those files with one simple little line of code. We're going to get you there by the end of next week. You're going to be using wildcards like this. You're going to be redirecting things to files with that and that. You're going to be chaining together these short little commands with the pipe. Okay, so that's where we're getting. So if you want to look ahead, because we're not meeting again until Monday, right? Yeah, it's kind of crazy. I wish we had more time. If you want to look ahead, week 2, it'd probably be worth your time going through remedial Unix shell, your basic Unix commands here. This tutorial, I've got a couple short papers that will help you get over your anxiety on the value of command line bullshittery and the annoyance of it. This, useful for bioinformatics. This is a nice little repository. This is somebody's GitHub repository, Stephen Turner. God bless this man. He's so useful. These are all one-line little things that you can copy and paste, and it tells you what they're doing. All right, they're all super handy. These are all bioinformatics focused. Okay. Convert a fastq file to a fasta. Well, I don't know how to type that, but I know how to go here, copy and paste it into my terminal, and it works. All right. So go through there, look at those. I've got 3 videos for you on kind of getting the hang of your terminal, your first commands. We've already gone over most of those. Pipes and wildcards, you've seen those, but we haven't worked with them yet. It'd be helpful to watch those first. And then we're going to spend a great deal of time next week talking about relative versus absolute file paths. Okay, so seeing that video will kind of help prepare you for what we're covering in class. There are a couple reasons why I start you out. I know this is a data analysis class, and we're supposed to be learning R and how to make pretty graphs, and we've already spent a week in this boring black box of command line text. There are a couple reasons. One, if you're doing bioinformatics, this is the way. 2, this will help teach you about file paths. And that's been my biggest hang-up, honestly, teaching this class in the past, is people don't really understand what this means or why CD ... desktop works. Okay, so next week I'm going to focus hard on that, so please watch those videos ahead of time. We're going to be using these file paths. It's just instructions for your little friend in the computer to move back and forth through your folders. Okay, but we're going to be using them with wildcards and with our pipe, and we're going to see some pretty cool results. Okay, assignment 2 is all in the command line. Okay, so if you haven't done it already, which you have, there's the instructions to get my data course. And then you've just got 6 tasks. All right, and what I want you to do is copy and paste the instructions that you found to accomplish that task into a little text file, upload that to Canvas, and that's what I'll grade. Okay, so we're going to be looking through word count, sort, head, tail, cat, and then redirecting things. Questions?
Yeah.
Okay.
Not with anything that you just necessarily talked about.
Fine.
All right. So when we made a repository, we clicked on a box to make it a README. What did that do?
That started your online repository with a stupid little file in it already called readme.md. If that wasn't there, you can't do git clone.
Okay.
Because it would say, you're cloning an empty repository, nothing to put here.
Yeah, I did run into that.
Okay.
So,
yeah, so checking that box is crucial to be able to bring it to your computer right away.
With that, we did things in the last assignment where we specified readme.md, right? Mm-hmm. But if you have more than one repository that you've clicked as a README, how does it know which one you're referencing? Is it that your file pathing that you've gone into?
Yeah. So here I am. I'll go. So I'm in my data course. There's something called readme.md right there. Cat readme. That's just what you're seeing on the screen here. All right. You may notice that this is a link, the course website. I specified that in my README by putting it like that. Okay, so this is a markdown document, not just a plain text. Now, it knows that that's the README file I care about because I'm in that Git repository. To deal with the other README, I'd have to go cd ... cd data course zon. Look around, there's README. Cat README. Does that answer your question, or maybe I misunderstood you?
Yes, that does. Now, let me throw you a situation.
Great.
You have, let's say, our personal data course file. So data course hall.
Mm-hmm.
It's got my README in there. Let's say I shove another README inside that folder.
Oh.
What's that going to do?
You can't. It will overwrite it.
Okay.
Let me show you this just using the little explorer here.
Yes.
I'm going to say new file, data course. I'm going to do it from the command line. Okay, so I'm in data courses on. I'm going to go to my desktop, look around. If I cat readme.md, it's going to say no such file. Okay, great. I'm going to make one. I'm going to echo some stuff, send it to readme.md. So I got two files named the same thing. They're sitting in different folders.
Yeah.
All right. So I go here to my desktop. There's readme.md. I'm going to copy that. Go into data course Zon and paste. See? It's saying, you sure you want to replace this?
Okay. And
now, if I do it from the command line, I can say copy readme to data course Zon. It'll just do it. The command line will let you screw your computer up. It'll let you overwrite files. It will not ask permission. You see how it just did that? So now if I go into data course Zon, I look around, there's readme, and I cat readme. It's just that one line from the new version. It's not the old one with all my stuff in it. It overwrote it without any moral qualms.
now,
You can't have two things named the same exact thing in the same directory.
got it.
Yeah.
So, is readme.md just the designated name for a repository for GitHub to work with, more or less?
Yes. If you have something called readme.md, it shows up automatically on your GitHub page here. That's the only thing that's special about it.
So
that the GitHub website looks for a file called readme.md. If you don't have one, it doesn't care. If you do, it'll automatically print the contents to the website.
So if I went into my file explorer, went in through everything, and changed that file name to something else.
I'm going to do that right now. I'm going to change by moving readme.md. I'm going to move it into blah.txt. Once again, it does not ask me, are you sure you want to change the name? I look around, readme.md is gone, blah.txt is there. I can cat it, and it's got the same contents. Now I'm going to git add everything. I'm going to git commit with a little message that says mess up. I'm going to git push. Geez on.
Repository not found.
Oh,
okay.
because I deleted it offline. I forgot. If I had done that and I hadn't deleted it from the internet, it would show up. It would have the little file here, but it would not be displaying it. That's the only difference.
All right.
It's
so
just like a handy, if you do name something readme.md, the website will show it to you right off the bat. And so people typically use that as a way to like introduce the project, to say, here's what this project's about, so you don't have to go looking for it. If you look through any of my other repositories, I'm going to click on repositories here. You can kind of get a feel for some of the stuff. So here's CO2 sponge fungi. There's my README. It's just a kind of a note to people who may find this, what's going on.
people use it as like an introduction to what the repository is about.
Yeah. Mm-hmm.
Okay.
It can get pretty complicated because the markdown format will let you like insert pictures and all kinds of stuff. So it gets kind of out there, but people typically use it pretty simply. CV wall. This is a friend of mine. Coral isotopes across space and time. He does a really good job with his repositories. So you can see he's got a lot of info in there. So you know what is in each file, what the column names actually mean, all that good stuff.
Okay.
Yep. All right, we are out of time. Fix your weird spelling and capitalization in your repositories if you don't have those right. I will be grading those on Friday. The way I grade them is Git repositories, data course. I go into student repos, fall 2020. I look around, I see who's there, and I've made a little shortcut. And it tells me if they're up to date or if they've been changed. All right, so there's been some changes. I'm just going to do that on Friday evening and grade what I find. All right. So make sure those are in good order. It would probably benefit you to look ahead and go through some of the resources here for week 2. That'll set you up for success once we start talking about file paths and working in the command line. After week 2, I've got some exercises for you that'll help you practice this stuff, and then we're going straight into R after that. Okay.
I think I broke my black box. Any of the commands I type in are there, but it's not doing anything. What do I do?
Hit Control C.
Okay, thank you.
Yep. I probably should have told you all that earlier, but Control C is your like get out of jail free card. It stops whatever is happening in your terminal and just gives you a nice command prompt again.
Okay. Thank you, Dr. Zahn.
Something you don't want to accidentally hit if you're running a long program, right? You're analyzing some DNA and it's going to take 20 minutes and you accidentally hit Control C for copy or something.
Yeah.
Yeah. All right.
Good to know.
I'll see you guys on Wednesday. I'll be available here if you want to leave messages with questions or if you run into trouble, need troubleshooting, just dump them here on Teams.
Okay.
All right. See ya.
See ya.